Hello, what we're going to look at in this video today is angles in circles. Now you might think there's no angles in a circle. What we're going to do is we're going to look at a particular feature of drawing a triangle inside a circle, constructing a triangle that gives us specific angles that we can then work with using some knowledge of maths that we already have. Okay, so if we take just a circle here and we've drawn a diameter across the middle. Now remember, a diameter is a line that joins each side of the circumference through the centre. Okay, so the centre point would be here, and that's joining each side of the circumference through that. Okay, there's another type of line in a circle though, and that's called a chord. An example of a chord would be a line that joins 2 points in the circumference, but it doesn't necessarily have to go through the centre. So it would mean something like this. So if we took a point from here and joined it to there, now we can see that's not going to pass through the centre, but it's going to give us a line like that. Okay, so you'll need to find something circular at home to do your notes. Okay, so you have to draw around a cup or something like that, and then mark on the diameter, and then mark on a chord just like this. And you can actually put the chord to any point you like on the circle, and you'll see why in a wee minute. Alright? Now, this is called a chord. So, exactly the same spelling as like a musical chord. And remember, it's a line that joins 2 points of the circumference of a circle, but it doesn't necessarily have to go through the centre like the diameter does there. Alright, so if we take the other side of the diameter and we join that onto this chord, something pretty cool is going to happen. What happens when we do that is that we get a right angle in here. And this is always the case, right? So you can see that if I trace that shape again, if I trace this shape all along the diameter, up this chord, down here, then I get a right angled triangle. We already can do a lot of maths with right angled triangles. We know how to do trigonometry, that's SOHCAHTOA. We can do Pythagoras, we can do converse of Pythagoras, we can do angles inside this. That's lots of things we can do with it, okay? So, just to go over that one more time, okay? We've got a diameter, so we've split the circle in two. So in effect, what we've really got is a semicircle, right? And we're going to draw a chord from the end of the diameter to any point here along the circumference of this semicircle. We draw it to there. I picked a random point, as you saw, okay? And then I took another chord and joined that up, okay? Now, if you do that, you will always get a right angle. Try it yourself, pick any point along the circumference of the semicircle that you've drawn. Any point could be there, you join it up like so, and you'll always get a right angle. Okay? So that's one of the fundamental points of geometry. Okay? So, next thing we're going to look at, and remember you can rewind that if you didn't get it, and I'll explain it all over again. We're going to look at two examples just now. Quite simple ones, just dealing with angles. So, here we have a right, so here's the first example we're going to look at here. We can see that we've got the diameter here, and then we've drawn our two chords to this point on the circumference, alright? So, we're looking for a missing angle, okay, and we can see that we've already got 21 here. Now, the most important thing we do with these questions is we always look for the right angle and mark it on first of all. So this is a right angle here, and now we're just looking at this right angle triangle and we're looking for the missing angle. So we should always remember that the sum of the angles inside a triangle add up to 180 degrees. So the sum of all these angles, so 90 add 21 add x, is going to give us 180 degrees. So if we know that, then we can figure out x. So x degrees is just going to be 180 minus 90 minus 21, which is equal to 69 degrees. So that's that first one there. Okay? Right, so looking at a slightly harder example this time. We don't have any numbers on here at all. Okay, we have no information. all we know is that we need to find this angle here. First thing we always do is we look for the right angles. Okay? So there's a right angle in here. That's where the two chords meet. So we know that that must be a right angle, and that's a proof in maths. There's no doubt about that at all. Okay? These little equal signs here tell us that this triangle, this right angled triangle, is actually isosceles, right? So that means that these two sides are equal, and also these two angles are equal, right? So if those two angles are equal, and they must all add up to 180, then x must be 45. Now, you might be asking, where did I pull 45 from? That's a bit of a random number. Well, if this is 90, that means that the number of degrees that are left is going to be 90. And 90 is going to be split equally among these two because they're both the same. So if you split 90 equally, you get 45. Okay?